We've managed to create a list of hockey players. We've added 3 hockey players onto the list, and we've seen that we can retrieve a hockey player and do something like print out their first name. At some point, we probably want to go through the whole list and do things with the list. For instance, we might want to print out the first names of all of the hockey players that are on the list. There's a number of different loop styles that are available for doing this in Java. The most common one that you'll see is the counted loop style, which is just a basic for loop. So you start at 0, you make I go through the range of all of the numbers that are less than the number of items on the list, and you increment by 1. The interesting thing about this loop style is that the for loop, even though it has lots and lots and lots of variations, this particular format is probably the one that's most commonly used. Invariably, when you're looking at lists of things, you want to start at the first one, go up until you've done the last one, and you want to go up by 1 each time. So the value of I changes in the loop, and we ask the list to retrieve a particular player at a particular position. So we'll go get the number 0 person off the list, and we'll put them into a person variable. After we put them into a person variable, we turn around and print out their first name. The variable isn't absolutely necessary, but the variable is a very handy debugging tool. In this case, if you were to put a breakpoint here, you can see what the value is that's coming off the list. If you just take this expression and change it to canucks.get sub I dot get first name, if for some reason it fails, it makes it very difficult to figure out what's going on when it's in one statement. Another common loop style is one that doesn't involve counting. The trick to this is to start out by making a variable which is called an iterator, and an iterator's job is to just go retrieve things for you. When you start the iterator out, you fill the iterator variable by asking the list to go get somebody for you who will retrieve the items off the list. So essentially it's like getting an employee from a warehouse, which is what the list is, and that employee of the warehouse will retrieve things for you. The pattern is one that we use all the time, and is probably a more natural pattern. You talk to whoever's supposed to retrieve things for you, and you say, do you have another one? So this is a question. If the answer is yes, then you ask that person to go retrieve that thing for you, and then you process it by printing it out. Then you go back up to the top of the loop again, and you ask the person who's retrieving things for you, do you have another one? If they say yes, you proceed to go ask them to get it and print it out. So the only thing that an iterator does is it's just a fancy way of saying I can answer 2 questions. Do you have another one, or go get them for me? And notice that in this style, once you've talked to the list to acquire that employee or that iterator variable, there's nothing in this code that ever mentions the name of the list again. So the word Canucks is never mentioned because the secretary is acting as the person who talks to the Canucks list and retrieves the objects for you. This style tends to be preferable over the counted loop because the biggest mistakes in the counted loop are not starting at the beginning or not getting the last one at the end. And in this case, the iterator is in charge of making sure it just retrieves all of the items for you, so it's very difficult to make a mistake. The problem with that loop style is that even though the pattern is fairly consistent, for instance, if we were doing something like retrieving sponges, this would just be iterator for sponge, go retrieve the list that contains the sponges, and then this word would be sponge, and we would do whatever we had to do with sponge objects. So the pattern is fairly consistent, and it really means that you're doing a lot of typing, and it would be nice if we could eliminate the typing. In the final version of the loop, we do this sort of thing, where we just say, for each hockey player variable name in the list of hockey players, just go print them out. This is known as the for each loop in Java. It would be nice if the word said for each here, but unfortunately for each wasn't a keyword in the language, so they had to pick a word that they knew that they had already, so that's why it says for instead of for each. And this thing here, this colon, the word in wasn't a reserved word in Java, and so they had to make a symbol that referred to the word in. So read this as for each hockey player person in the Canucks list, do something with it. All that happens in this abbreviated version of the for loop is that when you write this 3-line for loop, In fact, what happens is the compiler writes this for you. It makes an iterator that you just don't see, and you get some code that's really quite simple in the end. So we normally prefer the for each style of for loop if we're going through lists, because it's the most compact and obvious and error-free version. At times, the iterator version will come in handy, or at times, if we really need to, we'll go back and use the counted version.